Okay, let's talk about some words real quick. A sequence is a list of numbers that may form a pattern. Each number in a sequence is a term. Okay. When the terms of a sequence differ by the same number, the sequence is an arithmetic sequence. So if you can add or subtract the same number every time to get to the next number in the sequence, it's an arithmetic sequence. D is the common difference. So D would be like, or the common difference would be like every single time we add 4, every single time we subtract 2. So the first one we're going to look at is, they say, determine whether each sequence appears to be an arithmetic sequence. If so, find the common difference and the next 3 terms in the sequence. So we have, for our first example, 12, 8, 4, 0. Okay, so from 12 to 8, we subtracted 4. From 8 to 4, we subtracted 4. And from 4 to 0, we subtracted 4. So we have a common difference of -4. Okay, so then we can take 0 minus 4 and get -4, and then -4 minus 4 and get -8, and then -8 minus 4 and get -12, and those would be our next 3 terms in our sequence if we were going to keep going with that pattern. Then we have another one, B, and we have 1, 4, 9, 16. So from 1 to 4, we added 3. From 4 to 9, we added 5. And from 9 to 16, we added 7. So those differences, or what we added to one term, we didn't add to the next term. So it's not an arithmetic sequence. It's not saying there's not a pattern, but that pattern isn't progressing by the same exact number every single time. Okay, I just realized I wasn't recording. We are finding the nth term of an arithmetic sequence, and this is the formula we're going to use. A sub n, or superscript, yeah, n, equals A1 plus the sum of n minus 1 times d. A1 is the first term of your sequence. N is the term you are finding. And D is, like we said before, the common difference. Okay? So you're going to want to know or have that formula written down somewhere. Probably easier to write it down. It's not like a very common one. So the first one, we are looking for the 22nd term in the following sequence. So we have 5, 2, -1, and -4, and this thing keeps going. And now some of you are like, well, I could just write it out. Yeah, you could write it out, but what if they want you to find like the 516th term? There's no way either one of us is going to sit there and write down 516 numbers. So, first thing is find the common difference. So, remember from that we just compare. Okay, we subtracted 3, subtracted 3, subtracted 3. So we know the common difference is -3. So then we use that formula. AN equals A1 plus n minus 1 times D. So AN is going to stay. That's what we're solving for. Okay? And we are going to put 5 in for A1 because that is the first term of the sequence right here. Plus, we are looking for the 22nd term, so we're going to put 22 in for n because that's the term we are finding, minus 1, and we said the common difference was -3. So then we take order of operations, 5 plus 21 times negative 3. And then we have an equals 5 plus a negative 63. And an is negative 58. So the 22nd term of that sequence is negative 58. That is a whole lot easier than writing out 22 terms. So the next one we have is, they just tell us the following information. The 15th term, they tell us that our first term, A1, is 7, and that our common difference is 3. So we use the formula AN equals A1 plus N minus 1 times D. So we have AN equals A1, which is our first term of the sequence, 7, plus N, which is what term we're looking for. We're looking for the 15th, minus 1, times the common difference of 3. So then we have 7 plus 14, following the order of operations, times 3. And then we have 7 plus 42, I believe that is. And then we add, and we get 49. So really, if you know what A1 stands for, what N stands for, and what D stands for, and you know how to find those, you know that A1 is the first term of the sequence, N is the term you're looking for, and D is the common difference in the sequence, all you are doing is evaluating. So it's not like this big, huge, complicated thing, because you know how to evaluate, you know how to follow the order of operations. But I can also see how some of you are going to look at that equation and be like, oh my goodness, that's going to be really difficult, because I was the same way. So we have one more story problem. So the odometer on a car reads 60,473 on day 1. Every day the car is driven 54 miles. If this pattern continues, what is the odometer reading on day 20? So we're just using the same thing. We're using A1. Oops. Okay, I messed up, so I rewound it. So we're using AN, N, and D, just like we did before. Okay. So not AN, A1. What am I doing today? This is like the 6th movie I've done, so I think that's probably what my deal is. Okay. A1 is the first number of our sequence, which is 60,473. N is, what are we looking for? We're looking for the 20th day, and the common difference, it says the car was driven 54 miles a day, so that is our common difference. So we are going to use the formula AN equals A1 plus N minus 1 times D. So, and for A1, we're putting 60,473 plus, and in for N, we're going to put 20 minus 1 times the common difference of 54. So then we use order of operations, and we leave this the same, but 20 minus 1 is 19, and then we're going to end up timesing that by 54, and I need a calculator for that. Let's see here, calculator. Alright, so we're going to take AN equals, bring down 6473 again, plus 19 times 54, and get 1026. And then we're going to add those two numbers, so plus 6473, and we're going to get 61,499. 61,499. So on the 20th day, if you were driving 54 miles a day, the odometer would read 61,499, and I am under 10 minutes, so we're going to be done. Just kidding. If you want to stick around for one more where it's a negative common difference, You can. You don't have to. But, oh man. Some of you might get confused if you get to a negative common difference and you're like, oh, I haven't done this one. So the problem says, I'm not going to write it out, each time a truck stops, it drops off 250 pounds of cargo. After stop 1, its cargo weighed 2,000 pounds. How much does the load weigh after stop 6? So it started off at 2,000 pounds. So that's going to be our first number in our pattern. We want to know how much it will weigh after 6 stops, so we're looking for our 6th term. And the common difference, it says it drops off 250 pounds each time, so that's going to be a negative 250. Okay? I don't know if that was actually recording at all. Weird. I think it took forever to start. Okay, had another blonde moment. So we're going to use the formula AN equals A1 plus N minus 1 times the common difference. Our first number in our sequence is 2,000 plus the term 6 minus 1 times the common difference of negative 250. And then we have 2,000 plus 5 times negative 250, following the order of operations. And then we're going to multiply 2,000 plus 5 times negative 250 is negative 1,250. And then we're going to subtract those, and we're going to get 750. So that truck is going to weigh 750 pounds after the 6th stop. So now I'll be done.